all for coming tonight. And I want to give a special shout out to some members of the Watershed Council who just returned for the summer. I'd like to welcome you back. Good to see you at our first big event of the season. So this topic is one that both our members and the community at large have become very interested in. That's why we searched for a venue that could hold many people. It's also the reason we included the information booth session to give you a chance to talk to the parties involved one-on-one. Now we begin the question and answer portion of the program. As you know, we asked you to submit questions for this panel ahead of time when you registered. We received nearly 100 very thoughtful and relevant questions, and we really appreciate that. We obviously will not be able to get to all of those questions tonight. So we, at Tip of the Mitt Watershed Council, we grouped your questions by topic and accounted for duplicates. We then coordinated with the panelists to ensure that many of your submitted questions were answered during the presentations. And then we prioritized the remaining questions based on those asked most frequently, as well as those specific to our mission to protect water resources in Northern Michigan. So please note this. Even though we expect to run out of time, we will do our very best to help you get answers to the questions that we can't cover tonight. First, we are providing cards for you for additional questions that you may have or questions that were not covered. If you include your contact information on the card, we will follow up and help you get the best information that we can find for you. And this will include trying to get follow-up written answers to the questions, and we'll also connect you directly with some of our panelists to provide you with answers. And we may host another event, more like a workshop in the future. We recognize this system is imperfect, but we're trying to provide as much information as possible, and we appreciate your understanding. However, between the presentations and our Q&A, we should be able to address the majority of the submitted questions. And I do want to say, we've also passed out the questions that we're going to ask here tonight. There's 22 of them on that list, but after we saw some of the presentations, then we took a few off and added some that didn't get addressed that we were hoping it would address. So we've got a couple of, questions 1 and 2 are new, they're not on the list. Your list will begin with 3, and then some of those questions will be asked. Okay, so without further delay, let me introduce the panelists for the question and answer session. We have Brad Chisela, as you met, from Enbridge. John Griffin is Executive Director with the Associated Petroleum Industries of Michigan. Allan, Beshore, you met, one of our presenters from PHMSA. David Chisela, Manager, Gas Operations Section, Michigan Public Service Commission. And then we have Joe Haas, Supervisor of the Water Resources Division in the Gaylord office of the Michigan Department of Environmental Quality. Ralph Dollhopf, our other presenter, Federal On-Scene Coordinator for the EPA. And then we have Steve Keck, U.S. Coast Guard Sector Sault Ste. Marie. Randy Roth, Supervisor, Remediation and Redevelopment Division, Gaylord office of the DEQ. Greg Williams is the Director, Tri-County Office of Emergency Management. Mike Jones is here, Environmental Health Supervisor with the Health Department of Northwest Michigan. Then we have Bill Hazel, Director of Marine Services for Marine Pollution Control. Beth Wallace is a board member of Pipeline Safety Trust. James Clift is the Policy Director of the Michigan Environmental Council. And Jennifer McKay is Policy Specialist at Tip of the Mitt Watershed Council. So we're going to start with our first question, and it will be for Enbridge, and that is or will diluted bitumen or dilbit be transported in Line 5? Here we go. And there is support for one as well.
Thank you, Renetta. And so if I understand the question, you said, will diluted bitumen be transported in Line 5? And the answer to that is no, it will not.
Okay. The second question, also not on the list, is for PHMSA, and it's, what is the notification process to the public and local, state, and federal governments if Enbridge starts transporting another commodity, such as dilbit, through Line 5?
Well, under our definitions of crude oil includes diluted bitumen, so they're required to file annual reports every year, but it'll be under crude oil, and then crude oil includes diluted bitumen. So.
Okay. All right, so then a follow-up for Enbridge. What is synthetic crude? How does it differ from diluted bitumen or dilbit? And does synthetic crude sink if spilled in waterways?
So synthetic crude would be partially refined crude oil, and so it would be upgraded crude oil that goes through a chemical process to create to create a synthetic crude, as compared to dilbit, which is simply a blend of a condensate in a bitumen and a dilbit, or diluent to make dilbit. And the answer on the synthetic crude is it is considered a light crude, and specific gravity would be significantly less than water, so yes, it would float.
It would float.
It would float, yes.
I would like to follow up with that. And just as for clarification, is the synthetic crude, does it come from the oil sands where it is mined bitumen that is then upgraded at a refinery?
Oh, sorry. There's a portable one in the middle, too.
So you can create synthetic crude from any basin. On our system, it would come out of the Western Canadian Sedimentary Basin and/or the North Dakota system, but primarily the Western Canadian Sedimentary Basin.
I'd like to. Is this on? Okay. I think this issue of whether oil sinks or floats is a complex one. It's not. I'd like to comment on it. It's not simply a matter of what type of oil. It's not a matter of whether it's a light oil or a heavy oil. That's one of the factors that we have to consider. But there are other situational factors, such as how long, what's the discovery time? What's the recording time following the spill? How long is the oil out in the environment loose before response activities can begin? That's a huge factor. Is water involved? What kind of water? Is it a river? Is it a lake? Is the river in flood stage? What's the weather like? Is it 30 degrees or is it 90 degrees? If it's 90 degrees, is the oil separating and is the heavy oil becoming lighter because the lighter part of it is, or is the heavy oil becoming even heavier because the lighter part of it is volatilizing because of the heat? These are processes that we call weathering, and that's the slide that I referred to a few minutes ago. All of these factors combine to determine how oil behaves in the environment, and how it travels, and how it changes and transforms, and therefore how it is recovered and how much impact and damage it has. And this, over the past 4 years, I've been asked this question 100 times, and it's kind of a mission that I have to educate people to the fact that it's about more than just what kind of oil. It's what are the circumstances. So I'll leave it at that.
Thank you. We're going to move on to the next question now. What structure supports are required for the portion of pipeline on the lake bottom? This is going through the Mackinac Straits. Do we know if the pipeline is adequately supported, and what, if anything, is being done to improve the condition of the pipeline and its underwater support system? And that's
Yes, we do know how the pipe is being supported. We do on a biannual basis, or every 2 years, we run a remote operated vehicle to take a look at the pipeline along the bottom of the straits. And so we do identify, and each particular span is identified, numbered, and that's something that we are aware of that, and we do know that the pipe is adequately supported. In terms of how it's supported, it can be anywhere from grout or sandbags to something else. We developed a screw type of anchor that we're using on the Straits crossing, starting back in probably 2002 or 2003, which actually screws into the floor and it doesn't allow movement from the currents or anything like that. So when we do our updates today, and we are doing one this year, we would look, the repair that would be done on the spans would be done with those screw anchor type of supports. And I apologize, I don't believe I had a picture of one in my presentation, but it's something that we feel from an engineering perspective is certainly a state of the art in terms of anchoring for that pipeline system.
Okay. Some follow-up?
Joe, with the DEQ, just to be clear, the DEQ is currently reviewing a permit application for what we understand to be ballast saddles to anchor the pipeline. And that's available if you wanted to look at our QPAS database online. You can see where the status of that permit is. It's still under review.
Okay. Next question. Has Enbridge obtained authorization from DEQ under Part 325, Great Lakes Submerged Lands Act, for placement and use of the pipeline? If not, will you, and when? Also Enbridge.
So our pipeline would have been approved and constructed in 1953, and that would have predated the Part 325. So we would have had our pipeline approved under Public Act 10 from 1953.
Any follow-up?
Just that, that was an easement that was approved by the Department of Conservation that was predating DEQ, predating DNR. It's now held with the DNR, and they're probably more appropriate to speak directly to that. They hold that easement and would be overseeing that. That's really all I can add.
Okay. We're going to skip the next question on the printed page and go to the next one. What is the expected life of a pipeline like the Enbridge Line 5? How is this determined, and are the supporting engineering studies available? That would be for Enbridge.
Yeah, so pipelines are monitored on a very regular basis. I mentioned in my slides some of the internal inspections that are done looking at condition of the pipe. The longevity of the pipe is really determined by the condition of the pipe and how it's holding up, and we're able to monitor through the use of those tools. So I think for every pipeline it would have a different life. It would be based on what was the initial design, how was the pipeline operated, how was it maintained, what were some of the design materials that have gone in. And all those factors would determine the fitness for service of the pipe, and that would drive any decision that we would have around replacement of a pipe segment.
Follow-up?
Yeah, just kind of as a follow-up to that, the thing to keep in mind is that the steel itself doesn't age, if you will. I mean, the wall thickness may be reduced because of corrosion, but if you can mitigate the corrosion and prevent that from happening, the strength of the steel doesn't just change over time. Now, certain vintages of pipe have had construction problems. For example, pre-70 low-frequency ERW pipe has had issues with seam integrity, longitudinal seam integrity. So we've addressed those issues by focusing on mitigating that threat long-term, and not necessarily just because of the age of the pipe, but because of the vintage of its manufacture. So if you focus on the threats to the pipe and not necessarily the age of the pipe, if it's properly maintained, it doesn't wear out, if you will.
Specific to five?
Yeah, I do have a quick follow-up question. It's been mentioned several times that this pipeline is seamless. I think that's a little misleading because there are segments of pipeline at the Straits location that need to be welded together. And I wondered how Enbridge has been monitoring the welds and how frequently, and is that something you can do when there's sediment on top of the pipeline?
Yes, very good question. And in fact, there are welds, circumferential welds, welding joints of pipe together. Typically, when you're talking about pipe seams, it's longitudinal, running the length of the pipe joints. So there would be no seams in the pipe. There are pipe joints, and yes, we do inspect those. And in fact, In 2014, we'll be doing what's called a tethered tool through the segments, which will look at each pipe joint from the interior, and it'll use the latest technology in crack detection to monitor each well through that segment.
Okay. Looks like we'll be coming back to you. And next question is, how many regulators are there to monitor safety of pipelines across the country, and specifically, how many for Michigan? And this will be for PHMSA.
We're approved, I think, for a total of inspection and enforcement personnel of close to about 140 nationwide. Like, as I mentioned, I'm out of the Kansas City regional office. There's about 25 of us, I think, in the region office. There's a couple, we actually have an engineer inspector that actually lives here in Michigan. But we don't necessarily assign folks a specific geographic area. They're assigned activities for inspections or failure investigations and things like that as they come up. Now, to supplement that inspection staff, as I mentioned in my presentation, we work with the states, and so there's an additional 300 or so is the number that I'm remembering of state personnel that do the inspection and enforcement activities for the natural gas distribution systems in their states.
Yeah, I'd like to follow up with that. Specifically in Michigan, like Allan said, we do the inspections for the natural gas pipelines. On the interstate pipelines, we do inspection. We turn our inspection results over to PHMSA, and they do the enforcement. On the state's pipelines, the intrastate pipelines, we do inspection and enforcement. And currently, we have 8 full-time engineers in the state that are dedicated to doing pipeline inspections, specifically to the natural gas pipelines.
Okay. Anything else? All right. So next question is, why does the state not have authority over oil pipelines in Michigan? And has the state of Michigan considered taking over authority to improve protections for our Great Lakes and other water resources?
Again, I'll take that question and specifically talk about, yes, there has been consideration, but it would take a legislative process. We would need to have a law in place for us to specifically regulate the intrastate lines. And we could do that. There's an additional program with PHMSA that we could take over responsibility for that. Currently, there is no law that gives us the authority to do that. So prior to being able to do anything, we would need the authority under some statute to be able to do that.
Okay. PHMSA, you want to?
No, I guess just to kind of clarify, all the interstate enforcement activity, whether it's done with Dave's personnel and under that cooperative program with the state of Michigan, has to come out under our authority because of the interstate pipeline status. So that's why we have to do the enforcement, even though they can do the inspection activities and then plan and bring that to our attention for us to follow up on.
Okay. James, did you have a follow-up?
Yeah, my understanding that there's certain kind of levels of oversight that a state can undertake, certification, other things. Can we get a little explanation of kind of the different levels that different states are authorized to undertake?
I'll take the first stab at that. Yeah, there's specifically, with regards to pipeline safety, there's 4 programs. There's 2 for liquids and 2 for natural gas. And they're split between interstate and intrastate. And in Michigan, we just have the 2 programs for the natural gas. So we have inspection of the natural gas interstate lines and inspection enforcement of the natural gas intrastate lines.
I'll just follow up a little bit on that. It's much more common for states to extend over the interstate natural gas pipelines than the ones that adopt the authority and get involved into the hazardous liquids pipelines side of the thing, because there's 2 different regulatory parts that are involved, and so there's additional training and things that they need to get involved in to do the hazardous liquids pipelines inspection and enforcement. In Central Region, the only state that does hazardous liquids is in Minnesota. Minnesota does inter and intrastate, both natural gas and hazardous liquids pipelines. But none of the other, Indiana adopted authority over intrastate hazardous liquids pipelines just in the last couple of years because of some short carbon dioxide lines that they wanted to take responsibility for. But other than that, the central region, all the hazardous liquids pipelines are inspected by us.
Beth, did you have a follow-up?
Yeah, just to point out, the reason why it's great to have the state do certification or take on this authority to do inspections is obvious. Obviously, the NPC is familiar with the area and local and easy to contact, and it's also a huge transparency point. It's much easier to get information and to communicate with our local state authority versus managing the federal system.
Okay. Next, go ahead.
I'm sorry, I would just like to add,
Yes.
as far as the DEQ goes, under the Natural Resources and Environmental Protection Act of 1994, it's Public Act 451, we would have authority as far as DEQ goes for the placement of structures in wetlands, in lakes and streams, or on Great Lakes bottomlands. So in the modern era, we do have authority under any structural placement in those sensitive areas.
Okay, thanks. All right, next question. Enbridge did address some of this in their presentation, and we'll come back to them, but we're going to start with PHMSA. And we wanted to hear the answer to this question through the eyes of the regulators. So the question is, what lessons were learned from the Marshall spill? We'd like to hear from PHMSA and EPA on that. Could you start with that?
Sure. In fact, I was reading an advisory bulletin we just issued last month, or a couple months ago in April, outlining some of the lessons learned for the rest of the industry to take into consideration in their programs. And so I refer you to that. I laid it down somewhere so somebody may be reading it now. I don't know. But anyway, I don't have it in front of me, but I'll refer you to our website that's out there. And it summarizes some of the things that some of the deficiencies that were identified by that investigation, and some of the things that we've been doing to try and address those deficiencies. Brad talked about what Enbridge is trying to do. We were involved in also out on the website, there's a corrective action plan that addressed the Lakehead system that we've been working, overseeing with Enbridge on. But the other thing is we're trying to apply those learnings to the industry as a whole. And so some of the deficiencies that were identified, for example, with the review of the spill response plans, we've staffed up our group that reviews those plans and approves them. We've gone through and we've reviewed a bunch of those, and we're releasing those out into the public website. So if you go to our website and go into the FOIA reading room, there's some 60 plus spill response plans that have been reviewed and approved and posted there. And there's another, I think there's a total of 300 and some. So we're in that process of getting that information reviewed and approved and released in a public version. Some of the things that we have rulemakings underway as part of the Act of 2011, there was a lot of studies that we had to do. Some of those were prompted by the Marshall spill. Some of those were prompted by the accident in San Bruno, California, that you may have been aware of as well on the natural gas side. But some of those apply. There's consideration of leak detection regulations. There's a docket underway to look into that. There was a report that was done on leak detection systems for Congress that's on our website if you're interested in reading that report. There's a study that was done as part of that act on remote control or automatic shutoff valves. And so that report is on our website, and that's you can read that if you and that's part of the docket, considering additional rulemakings as we go forward. There were some issues with the control room, and as a result of the Kalamazoo spill, we implemented, or we came out with a set of regulations for control room management that addresses issues like fatigue and alarm management and some of these other areas of control room operations that previously didn't have any regulations involving them. So we've done that. We're looking at As part of our integrity management reviews, we've tried to come up with additional requirements for performance measures so people can, measure the improvements that their systems, or if there's, the opposite of improvements. Anyway, so they can measure, they have meaningful metrics to measure their programs and whether they're effective or not. We've actually gone through there was public awareness activities were mentioned, and we have some relatively new requirements for public awareness. We've gone through, we've inspected all the pipeline operators in the country and done the first round of inspections on those regulations. So there's been a lot of activity that we've done as a result, not as a result, but since that accident occurred.
Thank you.
So I'll pick up on the public awareness lesson. I was talking with someone before the session at my table out front, and I mentioned this issue as a major takeaway from the Marshall spill. We all know there were delays in reporting and notification of the release, big delays in response time, and that allowed the oil to travel a long distance, 2 miles, to get into the river. And Allan and Brad have both talked about adjustments that Enbridge has made. It ultimately is Enbridge's or the pipeline operator's responsibility. However, in the Marshall case, there was a low level of community awareness. For many hours, there were signs in the community that something was happening. People smelled it, they were calling the police, they were calling the fire departments. Nobody could figure it out because the public wasn't aware that the pipeline was there, and the first responders weren't sufficiently aware. I don't think that's going to be the case up here. I think there's a good level of awareness, and I am encouraged to see that. I think that's really important because I'm not suggesting that it's the community or the public's responsibility, but it is to your benefit to be aware. And I think that's a major takeaway. Other takeaways, and they're related, include the use of conventional technologies. In the case of Marshall, within the first few weeks of the spill, over 760,000 gallons of oil were recovered using conventional response techniques. Booming, skimming, vacuuming, excavation. Not rocket science. The same thing, the same way we cleaned up oil spills for decades. Now, in the case of Marshall, we had a sinking component, and that occurred progressively as the oil weathered, and ultimately it became about submerged oil. And the lesson there is that you want to get, in cases where you know you have heavy oils that you might sink, you want to get submerged oil containment in as soon as possible, in the same way that you get surface oil containment in. Okay? And then finally, if you're dealing with submerged oil, you have to get the science going early. Over the past 4 years that the Marshall response has been ensuing, there's been a lot of heavy science applied in modeling and monitoring and geomorphology to predict how submerged oil behaves and moves. And if you don't get that going early, it's not available to you down the road when you need to make decisions about how to clean stuff and where is the oil. So I'll leave it at that. Thank you.
Okay. Yes.
Just one quick follow-up to that. I think that the lessons learned are just vitally important, that we take the time kind of as we go through it to make sure that we're learning from it. And I think as humbling as it is for us, I think sharing some of those experiences with other pipeline operators, making sure they understand. And I personally got phone calls from others dealing with situations where they've asked me questions about our incident. And I think those lessons learned are just critically important.
Okay, yeah, go ahead.
Yeah, one thing I wanted to add to that is that a panel was given at the International Oil Spill Conference not that long ago in Savannah, about a month ago, that Ralph actually moderated. And Marshall spill was one of the primary case studies that was discussed there. But one of the clarion calls that I think came from that panel was that all of those lessons learned start to be integrated into the response planning mode, into the area contingency plans. And some studies be conducted of those response capacities within these regions, how these oils may act, and some pre-planning in that regard. So there is a forward movement in that I think Ralph championed there at the International Oil Spill Conference, and one of the speakers addressed that specific issue. So I'd like to put that forth as one of the directions that we're moving as oil spill responders, and getting that into the planning phase instead of the reactive phase.
Great, thanks. All good? Go ahead.
I just want to echo the community awareness. I'm from the area that was impacted. There's several people here that were impacted directly. And it just, Enbridge in particular, or any pipeline operator, just being involved with the community, talking about resources that could be impacted if there is a spill. And I also think, earlier there was a discussion about bringing in the trustees for the natural resource damage assessment process post-spill. Why not bring them in pre-spill and talk about contingency plans and areas that need to be addressed, specifically for locations that are of high consequence, very high consequence. I also want to ask a question, I'm sorry, I'm going to be very quick. I know there was a corrective action order following the Marshall spill. There was also a corrective action order following the Grand Marsh, Wisconsin spill, which was system-wide for the entire Lakehead system. And my question is, has that one been resolved? Is it completed? If not, why or how can system-wide expansions continue to occur on the Lakehead system when a corrective action order is in place?
Portions of that plan have been completed. It was, I don't remember the exact number, but there were some 13 different topic areas, if you will, of that plan covered, and some of those have been completed, some of those are ongoing, and I don't know, honestly, the current status of many of those. One of the conversations that I have quite a bit with people that they don't understand is that our regulatory scheme talks about operating pressures because operating pressures are what causes the stress on the pipe. Now, their capacity changes can occur without ever increasing the operating pressure on the pipeline. So the maximum operating pressure on a pipeline segment is established by our regulations, but not specifically even Enbridge, but historically many companies, when they installed a pipeline to begin with, they would go ahead and buy a parcel of property halfway in between compressor stations, for example, because they anticipated that the capacity would be increased as business, transpired over the course of the year. So it's not uncommon for people to plan ahead when they install a pipeline and then come in and add compressor stations that were basically planned all along in between existing compressor stations or in between pump stations. The maximum operating pressure was established by rule, by regulation in accordance with those regulations, but the capacity is increased by that additional horsepower pumping capacity. One of the other ways that capacity can be increased is by a drag reducing agent, which decreases the friction along the pipeline wall, and so it takes less horsepower to move the product. So it doesn't fall under our regulatory scheme because they're not revising their operating pressure upwards to where it would exceed what their maximum has been established at.
Are you okay? Yeah, okay. Steve?
Now, it does affect the emergency response planning, and that probably was what this gentleman was going to talk about, because their facility response plan is based on a worst case discharge. And so if their capacity is increased, there would be an increase in their worst case discharge potential, and that would have to be accounted for in their planning purposes.
Go ahead, Steve.
Yeah, I just wanted to point out your question there about pre-planning, contingency planning. I am the contingency planner for the U.S. Coast Guard for this AOR, and we do contingency planning. And in fact, we just had our last area committee meeting on Thursday, which consists of 66 different agencies throughout the local area to include federal, state, local, tribal, academia, industry. They're all involved in that pre-planning. So, and we are looking forward, as pointed out by Bill Hazel from Marine Pollution Control, about non-buoyant oils. All these things are already being looked at. Oil and ice recovery is being looked at. Particularly in the Straits of Mackinac, we did an exercise in 2011, we did an exercise in 2012, we did an exercise in 2013, all in oil and ice conditions, and we have an exercise planned for 2014. So,
The tribal was the one I was wondering most about.
yeah, actually we have six different tribes, and Chippewa Ottawa Resource are all members. And our counterparts on the Canadian side also involved there, First Nations as well.
Okay. I'm going to ask two questions of Enbridge next. The next question and then two questions down. And you did cover some of this already in the presentation, but I think it would be good to clarify and reiterate. The first is, how are pipeline leaks detected, and how is the line shut down once a leak is detected? And then the follow-up, how long will it take to completely shut down the pipeline once a leak is detected?
So how are pipeline leaks detected? We have several ways to detect a pipeline leak, and it really starts in our control room with our control center operators who are watching the pressures along the pipeline system with each pumping station and looking for any particular leak trigger that they can identify from normal operation. We also have a mass balance system, a leak detection system, which measures flow, mass going in the pipe versus coming out at our designed location. And it's a continual comparison between flow in, flow out. And if there's any discrepancy between one or the other, it's going to send a trigger again to the operator or put the pipeline into shutdown. I mentioned in my presentation the location of some auto close valves. Those would be...
Enbridge Line! Stop line 5!
Those would be, control valves would be monitoring pressure reductions. When it sees a pressure drop, they would automatically go into a closed cycle and shut the pipeline down. We also do, as I mentioned, aerial patrols. And so as we're flying the pipeline right away, and we're watching for, and I think Ralph's presentation showed some pictures of sheen and things like that, if it's a water body, looking for spots along the right of way, that type of thing. And then public input, as we're getting the public consultation and people being aware of an odor, they know who to call and for us to investigate. So a number of different ways that pipelines are detected. The second part of your question is how long will it take to completely shut the line down? And the answer is very, very quickly. We have put in electric operated valves in a lot of key locations. Those are basically at the fingertips of the control center operators, and when they hit an auto shutdown, they're going through it. On a 30-inch pipeline, the valve is probably cycling shut in about 3 minutes. On a 20-inch pipeline, it would be probably about 2 minutes to go closed on that system, so it does shut down very quickly.
Any follow-up? Okay, so this next question was asked over and over and over and over again in many different forms, including one that could have opened a novel as far as the setup. But the question is, should a leak occur in the portion of pipeline in the Straits during winter with significant ice, how would it be discovered?
Yes, and so I think I'll go back to the list that I had talked about, and a lot of our pipeline, in fact, the majority of our 50,000 miles of pipe would be buried, and we wouldn't have direct access to see that pipeline. And so our leak detection efforts are really focused on how can we tell what's going on in areas we can't see. And so our leak detection, again, our mass balance system, looking for any change in operating pressures, is what we're putting in one end of the system, coming out the other end. On the Straits of Mackinac, we also have the ability, when that pipeline shuts down in a static condition, we're able to shut the valves on either side of the Straits and monitor what pressure is in that pipeline segment, valve to valve. And if the control center operator sees any bleed off of pressure, valve to valve, he knows there's something going on, so he's able to do a static test anytime the pipeline is down. And then finally, just from the overall access to the waterways and the time of the year, and we've done a number of exercises which Steve has mentioned. We continue to focus on and have responded to leaks on ice, and it presents different challenges. But again, as a responsible party, we have to address those challenges and be ready to respond, whether there's ice or not, and that's what we're focused on.
Yeah, sure.
Yeah, I want to say too that those oil and ice drills that we did, we tested many new techniques and types of equipment that we found, some of it to be very beneficial to finding the oil underneath the ice shelf. We use autonomous underwater vehicles, we use remotely operated vehicles to go underneath the ice. We use forward-looking infrared radar to detect the oil in the water column. We use an aerostat, which is basically a blimp that's tethered to give us a common operating picture and also allow us to see where the oil is in the ice. It's very, very rare, believe it or not, to have solid ice cover in the Straits of Mackinac. The ice conditions change all the time, depending on the currents, depending on the winds. A couple years ago, we had to almost cancel our drill because there was no ice in the Straits just a couple years ago, whereas this year we have real nice ice cover to practice in. But the techniques that we're learning in the Straits of Mackinac are being used in Alaska as well. And we have become the center of excellence for oil and ice recovery techniques that we're perfecting here in the Straits of Mackinac, and we continue to work on those. Some things didn't work as well as others, but that's the reason we do the exercise, to find out what equipment does and what equipment does not work. It's a continuing challenge, and we keep working on getting better at doing oil and ice recovery.
Okay, great. Any other follow-up? Okay. So we're going to go till 9 o'clock and continue these questions here, and we'll reevaluate at 9. All right, so next question here is for the Office of Emergency Management, Greg. The question is, how would the public be notified if a leak or break in the pipeline was detected, and how quickly?
Sure, thanks. So it's important to make a distinction here between a pipeline break or some kind of leak that the pipeline company is working on versus really a catastrophic break or leak that public safety is involved in. Because there's really two different classifications there. If there's something that the pipeline company is working on, the public safety is not involved in, we may not even be aware of it unless they feel it's appropriate to call us. But that's very different. That's a stark contrast from what happens when we have an actual release. And the public notification piece of this is vitally important because in the case of this release, or really any hazardous release that we have into the environment, we need the public to help us. So we need to get that information out to you as fast as we can. We may need you to leave your home or stay in your home or do any one of a number of actions for us. So that said, we've got a number of tools at our disposal to help get that notification. One that you may be very well aware of is the emergency alert system. That's been around for a good long time, and you hear that often for severe weather and for other community emergencies. But now we've got some newer technology these days, especially if you are a resident of the Charlotte, Sheboygan, and Emmett County area, especially if you live around any kind of site that you have some concern for. I would encourage you to look into our Be-Alert emergency notification system, which is a system that we have here, unique and special to our three counties. And if you're here, whether a business owner or a resident, or even a seasonal resident, if we have any kind of emergent public notification to make you aware of, we utilize that tool. So you can sign up for that. There'll be some information on the PHMSA website for you. That's a very quick self-registration, and then it's unlike the EAS system. This system actually will call you at home. It will send you a text message. It will send you an email. Any device information that you put in the system, it will find you, add those devices, and deliver that message to you. Thank you.
Sure. Health Department, anything to weigh in on this one?
I think you pretty much covered all that.
Okay, great. Any other follow-up? All right. Okay, next question. In the event of a pipeline failure from Line 5 or any other pipeline in the region, who responds, at what response time, and where did they come from? Realistically, how long does it take to marshal the personnel and equipment to actually start containment and cleanup of an oil spill? And we're going to go to you for this again, Greg.
So this is a pretty big question. There's lots of individual questions that are kind of loaded in here. So I'm going to take the first part of this and pass it off to Ralph from the EPA to follow up on. First off, when there's a pipeline failure from any of our pipelines, it could be Line 5 or any of the other pipelines in our area, obviously it's going to evoke a public safety response. And that first responder that gets there is going to be the initial eyes and ears and boots on the ground to do an assessment as far as how bad this is. And that could be a matter of minutes, it could be a matter of several minutes, it really depends. It's hard to answer that piece of the question specifically because there's so many pipelines in a wide variety of areas across our region. Some are very quick to get to. For example, if there is some kind of problem at the Enbridge pipeline in Mackinac City, we're going to have somebody there literally within minutes. If it's in more of a remote area and the first responders have to find it or travel some distance to get to it, it might take a little bit longer. It just really depends on the logistics and the particular area that it's in. But by and large, public safety would likely be the first boots on the ground, so to speak, to get there and do their rapid assessment and start getting some intelligence, some information as to what's happening on the ground. Ralph?
Sure. Just one clarification. I think Greg was referring to the government response and the first responder response, not including the company. I think there's an expectation on the part of EPA and the Coast Guard and Greg that the company would be the first one that would be there. And I know that Brad has mentioned that they've made some adjustments to upgrade their ability to be there. So here's how it should go. The company, the local first responders, meaning the Office of Emergency Management, police, and flight. That's almost always the way that it's contemplated. As that's occurring, there are notifications being made by the company and by the first response community to other entities such as DBQ, such as the Coast Guard and EPA, and very importantly, to the company's cleanup contractors, people like Phil Hazel with Marine Pollution Control. They are called, the cleanup contractors are called the Oil Spill Response Organizations. The acronym is OSRO. So the company, the first responders, the OSRO, meanwhile, Coast Guard and EPA are getting called and we're on the way. If it's a big one, even if it's not a big one, we're there to evaluate what it is. So that's the sequence generally, and there are many other notifications. One of the notifications that we are really encouraging and reinforcing is health departments, because oil spills always have public health ramifications. It's not just about fish and ducks and birds and shoreline. There are public health issues, and public health agencies have to be in the loop. So that's the sequence. All of what we just described can happen pretty quickly. And then it depends. It depends on what it is. It depends how small it is, how big it is. Remember the slide I showed about the phases of cleanup. The first thing you do is notify, then you assess. You have to know what you're talking about. Are you talking about 5,000 gallons, probably, or 5,000 with the potential for it to be 500,000? You got to know that, and you got to know where it's at. So it depends, and I'm going to let Steve take it from here and pick up with the next level, next tier.
Right, the next level, once the Coast Guard receives the NRC report, we're going to dispatch our pollution investigators, which will head down to the Straits, which will take them about an hour and a half to get down there. We have a 13-person ICS quick reaction team that will follow them. In our area contingency plans and our geographic response plans, we have pre-identified incident command posts set up on both sides of the bridge in St. Ignace and Mackinac City. We would open up those incident command posts. We have pre-identified staging areas. We have pre-identified boat launches. We would use those GRPs and the Enbridge tactical plan to start the response immediately. Immediately, we would order in more resources, and we start bringing in more and more people from District Response Advisory Team, our National Strike Team. Quickly, more and more reinforcements would show up. It would ramp up to a massive response, hundreds of personnel within that first 24 hours. But ideally, Secretary Sault Ste. Marie would have their pollution investigators down there within an hour. And like I said, that Advon team would probably be about 2 hours after that. We're also very fortunate that we have Mackinac Environmental in St. Ignace, which is fantastic. So we have an Osbro, which is right there on the straits, which in addition to first responders, obviously Mackinac Environmental will be the first environmental response people on the ground.
Bill, anything to add?
Yeah, please. I'd like to start kind of like with a little bit of a metaphor here, so we kind of put our mind around this idea. But if there's an accident on a freeway, it all starts with probably one trooper and one car, and then that trooper is trained to a high level to be able to initiate a response, and that's what we're talking about here is a tiered response. So initially we will start rolling the boom in, we'll start putting the skimmers in and so on and so forth, and building upon that until eventually the entire cavalry is here, so to speak. So that's the way it will look to the community. It's just like a traffic accident occurs, is that resources start to get brought in until we get our hands on this situation.
Time. It takes a lot of time to, well, I shouldn't say a lot of time, and that's a relative term, but it doesn't happen immediately. What we want to happen immediately is the initial response and the assessment, and then we want to get the rest of the stuff there as quickly as possible. In the case of Marshall, it took days and days to assemble 2,500 people and 200 excavators and 500 boats. It's just not all immediately available. So when you have a major worst case discharge, you have to expect that it's going to take some time to get everything rolling.
Now, with that said, OSROs in this case, my experience in regulation in this dialectic we're discussing here, that OSROs submit, or some OSROs submit, my company does, to a voluntary OSRO classification program with the Coast Guard, and I'll share some of the ideas that go around that. In the Great Lakes operating area, within a 6-hour time period, it's my company's responsibility to maintain readiness to be able to bring, within 6 hours, 6,000 feet of protective boom, 1,000 feet of containment boom, plus 300 feet per skimming system that's brought in. Oil recovery equipment, effective daily recovery capacity in the range of 50,400 gallons per day, and storage for that of 100,800 gallons of temporary storage. That's all within a 6-hour time frame to anywhere where I am listed as an OSRO, and I am in the Great Lakes from Buffalo to Duluth. Now, dealing with a worst case discharge scenario, my planning standard, and these are baseline minimums of what the readiness level I'm expected to maintain that classification, has a 60-hour time frame, and that has a 30,000 protective boom requirement, 300 foot per skimming system, an effective daily recovery capacity of 1,050,000 gallons, and also a temporary storage capacity of 2,100,000 gallons of oil. So these are the planning standards that we are held to, and these are the planning standards that anyone transporting oil that has a facility response plan needs to maintain main resources that are on par with this kind of thing. And in this case, we're talking about Enbridge, and Enbridge names us in that plan for Line 5, as well as, I believe, one other OSRO as well. So they have some duplication in that regard. So that kind of gives us the framework of response timeframes and capacities, minimum timeframes and capacities that are being espoused right now.
If I could,
I said 60 hours. 60 hours. Yes, sorry.
if I could, this whole issue is very relevant in the context of planning, contingency planning. This question is one that Steve and I talk about all the time in the context of these response plans that Enbridge and other pipeline companies are developing. This is an evolving, dynamic topic, and it's one that we're always looking at. It's one that we're striving to better understand and improve. And in regard to the straits, we have some questions about whether there are enough resources available to respond in a timely way, or if there should be more. We're in the process of evaluating that, and we are intending to have discussions with Enbridge. In the case of the other pipeline company, Mark West, we are evaluating their plans as well in terms of how quickly can they respond to different scenarios. We're evaluating the ability of the other response communities, the agencies, if you will, to respond. So all of those are factors that go into the plan. They're not done deals. We're looking at them. Anything you want to add?
All I would say is the plan is ambitious. There's a lot of area to cover in the straits. We're protecting a lot of areas, so as Rob pointed out, that would require a great deal of resources, like Bill already mentioned. And again, yeah, ideally, we'd love to see a fire truck in every driveway, and we'd love to see more resources in the area.
Yeah, and I guess just in response to that, there's been a great discussion on all the different agencies. We do maintain people within our organization. That is a changing dynamic. We're adding people all the time, and I think exercises, when we get together to do joint exercises, it is a good time to take a look at who do you bring to the table, do you need more, where do you need more, that type of thing. And so we don't just rely on our own people. We have them trained, but we also contract with the OSROs. And in a major incident, we would be getting the NRC call, we'd be making phone calls, the OSROs would be going, we'd be going, the agencies would be going. And I think at the end of the day, there is a forming period of time. It does take time to form, but I think you start talking in terms of hours, and before you kind of start talking about days. And so I think you do end up, with a lot of equipment, boom on the ground. And that's the importance of the ICS system, to make sure that as people are rolling into town, you have some semblance of structure as you bring all these people and resources and put them to work. So anyway.
Great, thank you. Okay, I'm going to make an executive decision here. I'm going to skip the next two questions, and my goal will be to ask the following question, skip the next one, and then finish with the last for the following two, and then we'll call it a night. So 3 more questions here. This follows right in with what we were talking about. What cleanup and containment resources, including length of boom, are available on each side of the Straits of Mackinac and in Indian River? And that one's for you, Bill.
All right, well, I'm going to state what boom I know is in these areas. These are companies and entities where I have contractual arrangements and agreements in order to access that boom. So what I'm telling you is boom that I know is there. Relative to the straits, I believe there's 4,500 foot of boom on both sides of the bridge itself.
So each side has 4,500 or total?
4,500 total.
Okay, thanks.
Yeah. It's, mile 55, so just under a mile.
Under 1 mile, okay.
Under 1 mile of boom is available in those 2 locations. And in terms of Indian River itself, there is a response trailer parked in Indian River that has 400 foot of boom on it. Now, spreading out from those areas, and I think that I should mention this part of it, 400 foot at Indian River, okay? There's 2,000 foot in Sheboygan, Michigan.
Ma'am, Okay, thanks. Just let him finish his answer, please. Thanks.
Okay, there's 10,000 foot, okay, in Rogers City, okay. There is, I believe, 3,000 foot in Kalkaska. And up in the Sioux, I believe there's 16,000 foot of boom. Now, spreading out from that range, okay, I have 10,000 foot in Detroit, I have 1,000 foot in Bay City, 1,000 foot in Marysville, 1,000 foot in Marne, 500 foot in Gary, Indiana, 1,000 foot in Toledo, 1,000 foot in Duluth. That's just marine pollution control.
What quality?
Good, very good. Inspected boom, annually inspected boom. All of that boom that I just stated. So that's the reality of my picture of boom that I know is available for these response areas. And from those mileages and so on and so forth, you can draw the conclusions of what Ralph was referring to. Okay, that it will start out, you know, with pinpoint accuracy, and then it will cascade into a larger and larger operation. Those are my inspected, vetted locations. I know that boom is there.
Okay, thank you. We're going to go on to we're going to skip this one and go to, has anyone generated a three-dimensional hydrodynamic flow model of the Straits of Mackinac that has been used to predict dispersion patterns from a range of oil spill scenarios? If not, why not? And we'll start with Enbridge on that one.
Yeah, so our planners do consider 3D in doing their dispersion modeling, and that factors into our tactical response plan and how we would look at plume deployment and where it moves. And we don't typically, I know the other agencies use their own dispersion models, so they'd have to speak to whether they use 3D, 2D, or what technology.
Steve, any response there?
We have trajectory models on file in our geographic response plans and our ACPs. Those are developed by NOAA, so we do have trajectory models. As pointed out, just something we don't share for security reasons, but yes, we have trajectory models on file.
Okay. Follow-up? Beth?
If anyone is interested in seeing a 2D model, I do have one, or you can contact me. My email is wallaceb06@gmail.com.
And we'll supply that too in follow-up. Okay. And then, any other follow-up there? Okay. So now the final question then, why are automatic or remote shutoff valves not required to be installed at all water crossings? Is this even considered to be a best management practice? We'll start with PHMSA.
Yeah, I guess I really can't answer a question on why this hasn't been done yet, but valves are required on each side of any water crossing that's over 100 feet, excuse me, on new pipelines, new hazardous liquids pipelines. There's other specific requirements, and another one that's a little bit more difficult to evaluate is if they can reduce the potential for significant pollution, or it's worded somewhat like that. So that's more of a subjective evaluation. Those valves are required. It's not required that they be automated. So if you look at an old pipeline, there'll be valves on each side of every river crossing, but sometimes they're very difficult to get to. Now we have a rule, potentially you have a docket set up for rulemaking. We've done a study that was completed last year on the effectiveness of installing automatic shutoff valves or remote control shutoff valves. And that study's out there if you want to read it. That study's going to be used as a potential in the docket as a potential rulemaking. From the practical perspective, new pipelines, people are looking at valves and they're installing automatic remotely controlled valves. That is the state of the industry. I can't think of any case where people are not actually remotely locating valves that I'm aware of on any kind of a new construction project. In addition to that, as part of the integrity management activities for companies to protect specific high consequence areas, they're required to evaluate